Everybody, welcome to my YouTube channel Easy Mathematics. We have yet completed two type of tests. One is the comparison test, another one is the D'Alembert's ratio test. Now we are discussing with the Cauchy's root test. So the statement for this test is, in a positive term series summation un, if limit n tends to infinity, un to the power 1 upon n is equals to L, where L is finite, then the series un is convergent if L less than 1 and divergent if L greater than 1, and the test fails when L is equals to 1. So just like the previous statements, here also if this limit where un is whole power of 1 by n, its limiting value L is less than 1, then convergent, and greater than 1, then it is divergent, and again the test fails when L is equals to 1. So let us validate this one with some example. So first example is given here. Test the convergency of the series summation n divided by n plus 1 whole to the power of n square. So if any function of this kind where the entire function is in the power of n, then we apply this Cauchy's root test. So now here un is what? Un is n divided by n plus 1 to the power of n square. Now if we take un to the power 1 by n, then we will find out after simplification it is n divided by n plus 1 whole to the power n. Now if we divide the denominator and numerator by n, then we finally get it is 1 by 1 plus 1 upon n to the power of n. Now if we take the limit on both sides, then we will find out this limiting value is nothing but the e. That means limit n tends to infinity, 1 plus 1 upon n to the power n is e. So that finally we will get the limiting value as 1 by e. We know the e value lies in between 2 and 3. So that as it is 1 by some value which is 2 or 3, in between 2 or 3, then this ratio is definitely less than 1. So we can write it as less than 1. Hence by Cauchy's root test we will find out this limiting value is less than 1. Hence we can conclude that the series is convergent. Let us do one more example. So the example is, here examine the nature of this series. The series is 2 square by 1 square minus 2 by 1 whole to the power minus 1 plus 3 cube by 2 cube minus 3 by 2 whole to the power minus 2 in this way. So here nth term is what? So un is equals to here given, it is n plus 1 by n to the power n plus 1 minus of n plus 1 by n whole to the power of minus 1. So this is your un. From here we can easily find out n to the power of 1 by n. We just take the entire power as 1 upon n. So if we simplify, then we will find out here it is n plus 1 by n to the power of minus 1. Why it is? Because just look, this n plus 1 is common in both the term. So if we take common this one, so its power is minus of n, and here outside it is 1 upon n. So finally it remaining minus of 1. That's why n plus 1 divided by n to the power minus 1 is common. Now the remaining term is here n plus 1 by n to the power n minus of 1. Then whole entire power is minus 1, because here it is minus n and here it is 1 upon n. So it is finally of minus 1. Now we should take the limit on both sides. So now if we take the limit on both sides, then what we will find out from here? So here if we take the limit, then as n tends to infinity, this part is definitely 1, because as n tends to infinity, 1 by n is 0. So that it is 1 to the power of minus 1, and here it is 1 plus 1 by n to the power n. For this one the limiting value is e, then minus of 1. So we will find out after simplification it is 1 by e minus 1, which is definitely less than 1 as e value lies in between 2 and 3. So from the Cauchy's root test we can say the series is convergent. So it should be noted for the Cauchy's root test that this type of test or this test is applied whenever the term un contains the nth power of itself as a whole. When the entire nth term is the power of n, some power of n, then definitely we apply the Cauchy's root test rather than the comparison test or the D'Alembert's ratio test. Let us do few more examples. So the first example is here. This is the third one. So 1 upon 2 plus 2 by 3 into x plus 3 by 4 square into x square. In this way, this one is your given series. So here un is n plus 1 divided by n plus 2 into x to the power of n. If we take the limit on both sides, where un to the power 1 by n is considered according to the Cauchy's theorem, so that we just find out this limiting value is x. Just have a look. The limiting value, if we consider this one, so the limiting value is x. Therefore, by Cauchy's root test, the given series is convergent when x is less than 1 and divergent when x is greater than 1. And definitely, for x is equals to 1, the test fails. So, why this test fails and how to validate this, that we will do later on. So, let us check one more example where un is given, that is un is 2 to the power minus n minus of minus 1 to the power n. So, this entire thing is in the power. Here definitely un is this one given. If we take the power of un as 1 upon n, then it becomes here 2 to the power of minus n, means here it becomes 2 to the power minus 1. Then minus of minus 1 to the power n divided by n. So, this one is now the new power of 2. So, after that, if we take the limit on both sides, then what we will find out from here? Then we will find out this limiting value leads us 2 to the power minus 1, as this is independent of n. So, it will remains as 1 by 2, and here 2 to the power minus of minus 1 by n. Minus 1 to the power n by n. So, this part is definitely 0 as n tends to infinity. So, anything to the power 0 is 1. So, finally, the limiting value we will get as 1 upon 2. So, which is less than 1. Therefore, by Cauchy's root test, the given series is convergent. So, here you should note that for any given positive term series, when we apply Cauchy's root test and the limit n tends to infinity un to the power 1 upon n is equals to 1, exactly the value when this limiting value is 1, then we cannot say definitely about the nature of the series, that the series is divergent or convergent. That is because for this limiting case, the series may convergent or divergent. With an example, we are going to validate this. So, the example is here. So, consider the nature of the series where the series is 1 by n to the power p. So, this one is a p series. Again, we are dealing with the example when the given series is a p series. So, if this series is given and its limiting value we consider, here un is definitely 1 upon n to the power p. So, its limiting value we consider, where we consider the power as whole, whatever the un is given, its power as 1 upon n. So, we just write 1 by n to the power p whole to the power 1 by n. So, if we simplify, then we will get the limiting value is 1. So, thus for all this value of p, when this limiting value is 1, we can say the test fails, though we know the series is convergent for p is greater than 1 and divergent when p is less than is equals to 1, which is an absurd thing. That's why when we find out limiting value as 1, we say the test fails. Anyways, so we come to know what is our Cauchy's root test. So, depending upon that learning, we should do few questions by yourself. So, for you, there are total 4 questions given. The first question is summation of 1 upon log n to the power n. Second question is summation upon 1 plus 1 by root n whole to the power minus of n to the power 3 by 2. Third question is summation of n plus 1 to the power n r to the power n whole divided by n to the power n plus 1. And the fourth question is 1 plus x by 2 plus x square by 3 square plus x cube by 4 to the power 3, in this way where x is greater than 0. So, hope you all can able to solve these answers. While you solve, after solving the questions, you should write your answers in the comment box. I am waiting for your answer. I hope you can able to solve all those questions. So have a nice day and thank you all.